Welcome to Trivia Fusion, where we dive into the fascinating world of military technology and aviation. Today we're exploring the incredible process of how fighter jets launch from and land on aircraft carriers. These floating airbases are a marvel of engineering, allowing nations to project air power anywhere in the world. When you think of a fighter jet taking off, you might imagine a long runway stretching out before it. But on an aircraft carrier, space is a luxury that simply doesn't exist. So, how do these powerful machines get airborne? The answer lies in the catapult system. Modern aircraft carriers are equipped with steam or electromagnetic catapults that propel the jet from 0 to 165 miles per hour in just a few seconds. Imagine a swimmer pushing off the poolside wall to propel himself forward. Similarly, the jet engine thrust pushes against a thrust pad, akin to the poolside wall, with the thrust acting like the swimmer's legs. As the jet's engines roar to life, the force against the thrust pad hurls it forward. This intense acceleration provides the necessary lift, allowing the aircraft to soar into the sky from a mere 300-foot deck. These catapult systems are engineering wonders themselves. Steam catapults use high-pressure steam to drive a piston that pulls the aircraft forward. The steam is generated in the ship's reactors and stored in large accumulators, ready to be released in a controlled burst. On the other hand, electromagnetic catapults, like the Electromagnetic Aircraft Launch System (EMALS), use powerful magnetic fields to achieve the same result. EMALS offers several advantages, including smoother acceleration, reduced wear and tear on the aircraft, and the ability to launch a broader range of aircraft weights. Once airborne, the real challenge begins: landing back on the carrier. Known as the trap, this process demands exceptional skill from the pilot. As the jet approaches the carrier, it must align perfectly with the landing area, a small and constantly moving target. The pilot lowers the jet's tailhook, aiming to catch one of the 4 arresting wires strung across the deck. These wires, attached to powerful hydraulic engines below deck, absorb the kinetic energy of the jet, bringing it to a complete stop in just a few hundred feet. This method ensures that even the fastest aircraft can land safely on the confined space of the carrier. To aid in this precise operation, pilots rely on the Fresnel lens optical landing system, commonly known as the meatball. This system provides critical visual cues, helping the pilot maintain the correct glide path. If the pilot sees the ball aligned with the green datum lights, they are on the right approach. If the ball is too high or too low, adjustments must be made swiftly to avoid a missed landing, known as a bolter, which requires the pilot to circle around and try again. The tailhook's design and the arresting gear system are crucial components of this process. The hook, located on the aircraft's underside, is built to withstand extreme forces and is checked meticulously before each flight to ensure it will perform perfectly when needed. Another crucial aspect is the landing signal officer, LSO, who stands on the deck and assists pilots during landing. The LSO communicates with the pilot, providing real-time feedback and instructions to help them adjust their approach. This teamwork is vital, as even a slight misalignment can result in a bolter or worse, a crash. The LSO's role is one of the most demanding on the carrier, requiring extensive training and experience. The arresting wires themselves are marvels of engineering. Made from high tensile steel, they can withstand immense forces, stopping a 50,000-pound aircraft traveling at 150 miles per hour within just a few hundred feet. Below deck, the wires are connected to a series of hydraulic engines, which gradually slow down the aircraft, dissipating its kinetic energy safely. In addition to these systems, pilots undergo rigorous training to perfect their carrier landing skills. This training includes simulated landings on ground-based replicas of carrier decks, known as Field Carrier Landing Practice, FCLP, and countless hours of practice on actual carriers. The goal is to make the landing process almost instinctive, as pilots must be able to react quickly to any changes or challenges they face during the approach. Moreover, modern aircraft carriers are equipped with advanced technology to assist pilots. One such technology is the Integrated Launch and Recovery Television Surveillance, ELARTS. a system of cameras and sensors that provide real-time video and data to both the pilot and the landing crew. This system enhances situational awareness and helps in fine-tuning the landing process. All of these elements, the catapult launch, the arresting wire landing, and the sophisticated guidance systems, work in perfect harmony to enable fighter jets to operate from aircraft carriers. It's a remarkable dance of technology and human skill, ensuring that these formidable machines can project power and defend our interests across the globe. This synergy of advanced machinery and human expertise allows aircraft carriers to remain a central component of naval strategy, capable of responding to threats and delivering decisive air power anywhere in the world. So next time you see a fighter jet take off from or land on an aircraft carrier, you'll know the incredible engineering and precision that makes it possible. Thanks for watching. If you enjoyed this video, don't forget to like, subscribe, and hit the bell icon for more fascinating facts every Monday, Wednesday, and Friday. And if you have any topics you'd like us to cover, drop them in the comments or fill out the suggestion form linked in my bio. See you next time!